Hello everyone. So in this segment we are going to see some constraint on specialization and generalization. So we know that constraint means some rule, some restriction that we want to implement on something. So when we are going to do the specialization and generalization from a entity type, we can actually enforce some constraint on them. So in specialization and generalization, we can have two different type of constraint. Two basic type of constraint we can implement. One is disjoint constraint versus overlapping. Okay, so disjoint constraint, here I can have two options: disjoint versus overlapping. I can have another constraint, completeness constraint, and here I can have two different options, partial or total. Okay, so disjoint constraint, if you remember, we are showing actually our specialization or generalization like that. So from superclass is each superclass is connected with a circle, and in the same circle is connected with the list of subclass. Okay, now in this circle I can have actually two value. So I can have a notation in this circle with like D or O. Okay, so it looks like that, either D, okay, or it can be the value with O. So using these two letter D or O, I can say whether this constraint is a disjoint or overlapping. Okay, so the disjointness I can specify using this two letter, either D or O. D means disjoint and O means overlapping. Now it specifies that the subclasses of the specialization must be disjoint. Okay, so if this is disjoint, disjoint will be specified by D. All right, then an entity can be member of at most one of the subclasses of the specialization. So disjoint means that an entity can be a member of at most one of the subclasses of specialization. Okay, so for example, here I have employee, and in this specialization is D stands for this specialization is disjoint. Okay, and here I can say that each of the employee is going to be either secretary or technician or engineer. Okay, so using the set notation I can show you it like that. Let's say E is the set of all employees. Okay, A, B, C, D, E, F. Okay, these are the set of all employees. Now secretary has A and B, technician will have C and D, and let's see engineer I have only E. Okay, so disjoint means if I now calculate the intersection between any of the subset with the subclass, there will be a empty set. Okay, now if I calculate the intersection, this will be an empty set. Okay, or technician with, I'm sorry, this should be this is engineer. Okay, and here I have employee. Okay, all right, means every employee can be either secretary or technician or engineer. Okay, so the intersection between any of the subclass, all right, any of the subclass will be null. All right, the same employee cannot be at the same time secretary and technician. All right, all right, so disjoint simply means an entity can be a member of at most one of the subclasses of the specialization. If this is not disjoint, the specialization can be overlapping. Okay, so each specialization can be either disjoint or overlapping. So by default this will be overlapping. Okay, So overlapping means the same entity may be a member of more than one subclass of the specialization. Okay, the same entity can be or may be a member of more than one subclass of the specialization. Now for example, here let's see, in our first example we had I'm sorry, so let's show you another example from car. So in this example we are saying that we have a superclass part, and this is a overlapping constraint, this is overlapping specialization. So same part can be manufactured part and purchased part. Okay, now if I have a set of each part, let's see, P1, P2, P3, P4. Okay, now I have another set for manufactured part, say P1 and P2 are manufactured part. Okay, and purchased part I have P2, P3 and P4. Okay, now here I can see that P2 is both manufactured part and purchased part. So using the overlapping we are allowing that the same entity can be member of more than one subclass. Okay, now another different type of constraint, I can have a completeness constraint. So in completeness constraint there are two options. The generalization or specialization can be total or can be partial. Okay, the total specifies that every entity in the superclass must be a member of some subclass. Okay, so if I have a subclass, if I have a list of subclasses and superclasses, the total specifies that every entity in the superclass, okay, must be a part of some subclass. All right, so let's see, I have employee. All right, I have here engineer, technician and secretary. Okay, if that's a total constraint, we are going to represent them using a double line. All right, like that. Okay, and the total constraint says that every employee must be a engineer or technician or secretary. Okay, every entity in the superclass must be a member of some subclass. There will not be any employee who is neither engineer, technician or secretary. Okay, now partial allows an entity not to belong any of the subclasses. Okay, so now if the constraint is a partial where we can represent just a single line, okay, if this is a partial, then that can happen that I may have some employee who doesn't belong to any of the subclasses. Okay, I may have some employee who is not neither a engineer nor a technician or a secretary. Okay, and I can show it using only a single line. Now let's go back to our employee specialization. Here again we are showing that this specialization here is a partial and this specialization here is a total. So how this is different is that partial specialization, partial constraint says that I may have some employee who is neither secretary, technician or engineer. Okay, and here also this is a partial. All right, so I may have some employee who is not a manager. Okay, I have some regular employee, so who only belongs to the superclass, who doesn't belong to any of the subclass. Okay, but here this one is a total participation, means every employee must be a must participate in any of the subclass. every employee must be either salaried employee or hourly employee. Okay, so if I now finalize here, this specialization is partial and disjoint. Here this specialization is partial and overlapping. So by default, if I do not have any circle here, okay, by default this is overlapping. Okay, by default this is overlapping, means the same employee can be like an employee and a manager. Okay, now here it is saying that this is total and disjoint. All right, so here we can have 4 types of specialization and generalization. So we can have disjoint and total, disjoint and partial, overlapping and total, overlapping and partial. And okay, and the default specialization and generalization, the default constraint is overlapping and partial. Okay, so how we are going to choose which constraint, it depends on the situation, depends on the requirement we are going to model in our mini world. Okay, it depends on our application software requirement. So I can have some additional constraint on specialization and generalization. So one additional constraint is known as predicate defined. So if the Boolean condition like a predicate can determine exactly those entities that will become members of subclass, then it known as predicate defined subclass. Okay, the condition is like a constraint that will determine the subclass member, and we can display the predicate condition next to the line attaching to the subclass. So if one attribute defines the condition for all subclasses in a specialization, it is known as attribute defined subclass. Attribute defined subclass or attribute defined specialization. Attribute is called the defining attribute, all right, of the specialization. For example, let's say I have employee, and from the general class employee I can create some special subclasses like secretary, technician and engineer, and these subclasses creation was based on an attribute known as job type. Okay, so in that case I can show that the attribute based on which we have created this specialization, I can show that attribute at the side of the line from the superclass. Okay, so I have this circle here, the superclass is connected with this circle, and by that side I can specify the attribute based on which I have created this specialization. But I can have also like a user defined specialization. Now if there is no condition that determines this membership, then the subclass is called user defined specialization. Okay, the membership in the subclass is determined by the database user by explicitly adding some entities to the subclass.